Ok, good. Je vais juste vérifier qu'on entend bien. Vertice. Hello everybody. Ok, ça fonctionne. Je vais mettre ça ici, comme ça je vois un peu dans le corner of my eyes ce qui se passe. Okay. I think it's time to start. Do I have everything ready? Let me check. My keynote is here, so it's okay. Good. Welcome to the second part of this stream about live coding led animation. The first part was quite actually the beginning of everything. I've tried to put some stuff together to better explain what I'm trying to do. And also, since the last time, I've improved the compiler and the parser, so we are now able to do more animation more smoothly. And I was able to migrate Pixel Blaze animation script to my scripting language without too much of an issue, because we're going from JavaScript to more C-like language, but it's not that complicated to do. Okay, so I propose we just start. Okay, so that's a presentation of what we are going to see tonight. So here on your left, you have a new view of the editor, the console editor, which is available on the ESP32, and on the right, what is actually what you can do now, what kind of animation you can do. Okay. Okay, the goal that I was trying to reach is actually to be able to write and execute animation without having to re-upload Sketch using Arduino IDE with PDF or Platform.io. Like in Pixel Blaze, that's a product that has been around for a couple of years now. You can upload script using web interface. The language is more based on JavaScript. And it's really nicely done. And you've got also the team from the Moon Modules project from WLED, who have written RTFX, which is actually doing more or less the same thing as Pixel Blaze. It's just a starting point, but it's already really powerful. And if you're using WLED, I definitely suggest you go and look for the Moon Modules to see what they can do, what you can do with that. Last time I was presenting that the stream, I was talking about Lua and Mercury, two interpreted scripting language that was able to implement quite easily. It works naturally on the ESP32, but it has very low performances. It's actually many times slower than writing a code in the Arduino IDE. 40 to 10 times slower for Mercury and 40 times slower for Lua, but it's fully interpreted. The environment I was developing for is actually an ESP32W room and a rover also, which got more RAM, which we're going to have a discussion about that later on. To upload, I'm using Arduino IDE with the Arduino Core 3.0.1, but I started with the 2.0.17, and it's still compatible in both between. To drive my lathe during the demo, I'm using my own driver, the clockless virtual drivers, that allows me to drive 48 parallel stripped in full parallel, meaning that I can create really high refresh rates, even with a lot of LEDs. For instance, for the 12,000 LEDs here, I'm able to refresh the panel at 130 FPS. which is way more than what you can usually expect. For the console viewing, I'm on Mac. I can use the command line screen, but I'm using also the serial app, which is kind of nice and really well done. Okay, a couple of disclaimers here before I can hear everybody screaming on the comments about what I'm doing. First, I wanted to create an environment which makes the SP32 self-sufficient. I'm coming from the background on programming on Amstrad 464 or 6128 or Commodore 64, and with only 64K of RAM, we had an OS and we've got a programming environment, even if it was only basic. And you could execute your code immediately, which is not the case. I know that's not what you usually do with MCUs, but I wanted to be able to recreate this kind of same environment. You know, you can have an editor, you create a program, and you execute it right away without having to compile, put it on the flash, etc., etc., etc. I've wrote a new compiler, but I'm not a compiler specialist, so please be indulgent if you've got some people compiler specialists in the crowd. Don't scream after me, please. I did not test Pixel Blaze or RTFX because I don't own a Pixel Blaze and I never upload WLED in one of my ESP32, I have to admit. Hence, I have no clue on the performance of this implementation. But as I wrote on Reddit and other streams, I would be happy to have some input from you guys if you're using either both of them, either one of them, to see if we got the same FPS. There's still a beta version, so you can have crashed during the demo, especially the console. If I forgot to close the program before saving, sometimes it crashes. You will see also during the night couple of animation that were done by that rancher. I suggest you go on his YouTube and also on his GitHub. He's done a lot of very nice animation for Pixel Blaze. Really impressive. I took 2 of them. I would really like to give him a shout out tonight for that. Okay, the approach, I need a different approach between Pixel Blaze and RTFX and what I've written. For RTFX, you've got and Pixel Blaze, you have one function which is a function render xy or index x and y. It's called for each LED and it's passing the coordinate of the LED, and it's a script. It's interpreted according to my knowledge. What I've written is a bit different. It's really writing a program like you would write any sketch on an Arduino IDE on platform IO, and also the script is compiled to a machine language. So you've got your script, it moved to assembly language and then to a machine language. Maybe one day I will skip the assembly language part because it takes a little bit of memory I will try to get rid of, actually, but for the moment that's what it is. So it's a full environment, as I said earlier. I've brought an editor which works on the SP32 that you can have a view on the terminal that can interact with the compiler. The main challenge that I had was actually programming a compiler and everything with 160K of RAM. Of course, the SP32 got 512K of RAM, but the way it's split in the memory is not like the S3 or the S2. 160 is actually locked when you flash your code, and the instruction RAM is not accessible unless you do some configuration within the menu config, but you need to switch to ESP IDF to do so. I wanted to keep it with Arduino IDE because most of you are using Arduino IDE for platform IO, and so I had to restrain myself to use 160K to do everything. But as I said earlier, lower spec computer could do more or less the same thing. So let's see what we can do with that. So my architecture. So everything is running on the SP32. You've got the compiler from left to right. You've got the compiler, the runtime. We can actually execute or kill a process, actually a code that's actually done by the compiler. You've got the console also, And you've got also every function that is stored in Flash compiled by the IDE that you need to use. For instance, I did not re-implement the show function of displaying pixels within my new compiler, but I need to be able to call that function which actually stored in Flash. It's actually a link. I won't like to say dynamic linking like in C, but more or less at the same point actually. I'm able to call external function which are actually stored in Flash. All these components, depending on the color, are totally independent. They can run independently from each other. But for the demo, I will have everything together. And the console is only here because I wanted my environment to be able to load files, rename files, and execute some commands. And also the compiler exposes to the console some commands. So to the console, you can say, add an external command to do such and such activities. Okay. And in the runtime can call the functions or retrieve the value of variables if you want to define like main variables for all your scripts. And also it gets the function from the result from the functions. Okay. That's pretty clear for now. Let me see. Just gonna say hello in the chat. To comment. Okay. So that's what I've been doing for the past couple of months. Okay, the link to external functions. So if you want to write, if you want to call an external function which actually stored in Flash, you need to pre-export it by external in void of it, and then you write what you return, the name of the function, and if you have parameters. In your IDE, you will have your static functions, which is declared, which does whatever you want, or also global variables. And then we're using the command add external. The first parameters will be the name that the function will carry inside the compiler, meaning the name to call it in the compiler. It's a function and it's linked to the function show inside my script here. The same, it can be a function or it can be a variable. Okay, let me just show you what it looks like. Oh gosh, it's here. Here. Here you see, for instance, I've got my function add external show. So now if I want to call the show function within the Flash, I can call that. And if I look at the show function in here, or that's show, or it's not the same. Here it is, show function is here. And I've added more than just the show pixel. I've also added a couple of functionalities to actually display the frame rate, etc., which is actually cool. And I don't know. Okay, let's display that again. Okay. Pardon my keynote. That's more or less everything. Okay, maybe I will come back to that later. Let's do a bit of demo. So let's code. Okay. Okay. So here you are inside of the, you are on the ESP32. Let me show you that if I can actually clear and relaunch the ESP. Here it is. So we are inside the ESP32. That's the command line tools that you've seen already. So I can list all my program, and I can list them with their size, etc. Okay, let's create the rainbow animation back again with the editor. So Control E. Oh, let's me back here. If you tap an help here, you will see what kind of command you have. So ls, cls, load, save, type, clear, echo, help, rm, set, highlight. They are all from all these functions here are from the console by itself, and all these here are coming because I've also instantiated the parser. So the parser tells the console, by the way, here is new set of commands that you can use. Control E to toggle between the editor and the console. Control P, I will use that later on. Control S. Here also, that's all of the internal console commands. Control K and Control R are actually also shortcut commands that are actually pushed by the compiler. Okay. So Control E. So I want to create my rainbow animation that I love to create. For the main, let's h equal 1 while h above 0. So forever. For int I equal 1, I less than 128, I plus plus. That's doing because I'm my panel is 128 by 86, 128 large by 86 high. For in j equal 0. T plus plus. You see, I've also implemented when I tap curly bracket, it's all directly put me two curly brackets at once. I need to define less, but I will do that later. So A plus 128 times J equal HSV. I plus G plus H 255, 255. And I say I'm going to do H plus plus. Okay. Now if I try to compile that, of course I'm missing the definition of late and HSV, and of course I need to show my function. Okay, I cannot compile that because this function do not exist. So what I'm going to do, I'm going to say I've got the show function, which is an external function. I also define, when I've pre-compiled my program, I've defined the LED buffer inside of the flash memory. So it's of the first 160 KB RAM, because it says also memory, but you could actually create your LED array here and do something. So it's a pointer to LEDs. And also I need to have my function which give me back an HSV int h int s int v. Okay. Okay. Void main. Okay, let's try to compile that. So the shortcut to compile and execute is Control R, up, And of course, first crash of the day. Good. Let's redo it again. Let's see. I need to see what I've done wrong. I should have saved the program before. Stupid me. Show external /ep lets external HSV CHP HSV and HINT HSV. Okay. Void main hash equal 1. Plus it's certainly here that I made a mistake. That's J plus I. CRGB. Oh là, HSV. E plus J plus H. So for show H plus plus. Okay, this time I'm gonna save the program. Rain.sc. Now you see first that now I've got colors because I've put highlighter also. Every program with extension SC got highlighted. That should be correct, I think so. External function expected. Here I did a mistake in line 4. Now you see here there is a star next to the file name. I can directly save it. And here it is. It's working. Oh, it's like that. Control K. The program has stopped. Control S, rerun. Here it's better like this. I prefer when it's going that way, that direction. Okay, so that's our first one. That's our first basic program. So now you see that you got loop, the while, the if, etc. Compared to last time, I had to go through a temporary variable to store the HSV. Now it's not necessary anymore. I can do it directly. And let's certainly what I've done just before is actually that I wrote something wrong inside the LED buffer, so I was writing outside of the memory. So actually I thought of that. Let's enter safe mode. Up. I'm going to say that my LEDs here are actually the array is so that's the size of my array. And let's try to write out of bounds 188, for instance. Okay. Oh, I forgot to save, to kill the prompt before saving. Load. I've got auto completion on the code. Oh gosh, it erased the rainbow. Like, okay. So I'm gonna do, in order not to reply, to recreate everything each time. I'm just gonna oh god. Sorry, that's always my mistake. I should not do that. But that's only because of the console. Void show. HSV. That should be enough. Oh, just a minute. I'm just going to copy that from one of my other programs. New sketch, open recent, new panel. Not going to write that every time. From C. Okay, here in pass mode, okay, I can do that. Here it is. And in the meantime, what I will do, I will say I'm going to define LED gonna call it off. No, H++. I did not define H. Save. Yes, it's HSV. Okay, good. Stopping. Now I'm going to enter into safe mode. I'm going to define the size of the LED. Okay. And I'm going to say my LED width is 130, for instance, which is way more because 130 by 96 is more than 12,288. And now I'm going to run it here. And here you see now I've got an overflow saying that I'm trying to write at position 12 12,350 and the maximum size is 12,288. So you can actually put that in your code if you want to try to actually avoid writing not on the right place in the memory, which is good because it's actually directly moving to assembly language. In the meantime, also you see they can define values. Just add one function here. You will understand the use of it. Void clear. That's just a function that clears all the let. And I'm gonna do it each time I run the program. I'm gonna clear just before. So now let's say I'm gonna write that on 64 by 64. But here I need to do, I'm gonna define a new value. So the define here works like in the define in C. It will replace automatically every occurrence of that schema by the value that you push next to it. Okay. So I re-execute Control R, and I'm just doing it in a small square. If I put 128 here, and you see it's practically instant. So I can do it quite fast. Okay, that's pretty easy. Let's try to, can we do something a bit more complicated? See, the auto-completion is really nice. Just got. Let's execute first, and then we see what we have. So a set of bouncing balls behind a rainbow. Okay, here we've got like 20 bouncing balls, I think. Can edit the code. Here, I will come to the import function later. Number of balls that I want to display. So let's say I'm going to display 50 balls now. Just to execute it. And now I've got 50 balls. I want to change the size of the balls. So let's say from 6 to 2. Here they are. Okay, let's do something a bit more fun. Okay, so now what's going on, that once a program is compiled into assembly, into machine language, it's stored somewhere in the memory. So I can just rerun it by doing that. So it will first, as you see, kill the executing program and relaunch the other one. And I can do it. Now I can, by using the arrow up on my keyboard, come back to the previous command and execute it at will. That's the kind of complicated animation you can do. LS. Oh, game of life. The usual game of life. And you see that's the compiling is almost immediate. I don't have anything really to do. Something else? Yes, load test sinus. Kind of a plasma animation. This. So you can also use control, you can use strings. So I can come here. So for those who know C, that's something which is actually really annoying. This is a scrolling. The point, I didn't define the point as character. for my demo. Recompile, re-execute, Control R. Look. Okay. If you see the program here, actually I copy and paste another program that I've done in Arduino IDE, and it's really nice. And you can see that you can now, right? Because if you see my first stream, I had issue when I would say there was too nested call inside a call of a function, but now there's no issue with that anymore. Okay, I can also change because here it's 100. I say 255. And here it changes, but it's, yeah, it's really, let's say 80, 70 even. Okay. Oh yes, that's something which is been done by Thunderbolt, who I was telling earlier. That's one of his animation. It's running on. Yes, that's a fractal animation that is done. And something is interesting here. I will put the parallel for those who know Pixel Blaze and RTFX. You will see the parallel I was talking about. So if I look at the code, I will come back to the ASM earlier. So I've re-implemented the fmod, triangle, and time version from the application. You've got the before render. So I just did a simple copy and paste of his code. The render 2x, exactly what is done. And because my in the RTFX is looping through the different coordinates of the pixel, the only things I did here, I'm calling the initial initiation, and for each frame I'm calling the before render, and for each pixel I'm calling the render 2D, and I'm doing the show. So exactly what the program with Pixel Blaze is doing. So I just need to do more or less copy paste of all the code. The only things I need to do, because in JavaScript it's var something, so I need to declare with the type each variable. So that's what I had to do. But now I'm here and I can also change. Yeah, thank you again. If you find the code to the GitHub, I can also. So let's. What happens if I'm doing that on 16 by 16? Running on very small. Okay, we don't see anything because and I can also change the parameter here. So I don't know if I put 1. And if I put 0.2, it's very small because it's a scaling of the animation. So I think it's 0.5 or 0.6, which looks the best. Another one, which is actually by him. Squared spiral. Oh yes, I've changed before. I've changed the parameters here. Yeah. I was playing earlier this afternoon with this parameters. Oh, I need to say that it's a float. Here it is. That's the original animation that is done. So I was just playing to see what happens if I'm modifying this parameter at runtime to see it's up and it goes reverse because the sinus is gonna, no, it's absolute value of the sinus, but yes, you can see you can play in parallel live with the code and execute it automatically. I just need to click Ctrl R because, but you can execute it automatically. Okay, what else do we have? Yes, we can also display some animation. It's display icon, I think. Yes. So you see you can play with sprites also. And the way you do it is exactly the same way you will do on I'm coming back. On your Arduino IDE, you define the array. Now I can do that, define a full array with variable. I was not able to do that last time. And then I've got here the palette for the ghost, here the palette for Mario, here the palette for the Cherish, and I'm just applying the pictures to everybody, and I've got a sinus somewhere here. It's the sinus for the position of the Cherish. But I can totally move that to, let's say, let's do it faster. And here the motion of the Cherish is a bit different now, but you see now you can execute directly. Okay, let's go back to, this is everything that you can do. Let's go back to the keynote. I wanted still to discuss about something. Integer and float conversion. So you can have integer value because you can have uint 8 bytes, 16 bytes, 32 bytes, and floats inside. Floats single precision, not double. I could implement the double, but it was double work, so I say single is enough. But I had to make a choice for the conversion between integer and float. So I choose the following. If you are actually, if you are dealing with float, everything will be considered on the right side as a float. So 1.3 plus 0.25 is 1.55. If the target variable is an integer, everything inside it will be changed into an integer. For instance, the 2.5 will be changed into 2, 3.5 into 3, 2 will stay 2, so it's 2 plus 3 divided by 2. So it's 2 plus 1 and it's 3. In integer mathematics, of course. But of course you can change the types, saying, okay, the float, but I want to consider everything as an int inside. So you put the int. For those who know C, it's kind of a reminder of something you can do. So it's going to be 1.3 plus 1 divided by 4. 1 divided by 4 is 0.5, so it's 0 in integer. So it's going to be 1 plus 0 equal 1. But you can say, okay, I want the result as an integer, but I want my calculation to be done as float. If you put float in front of an expression, everything will be printed as float, and then because the target value is an integer, it will move the integer value inside of it. So that's, I had to make a choice. That was my take of, once you decide, it's actually propagate the type between integer and float to the entire string. Control E. I guess I've got the program here. Yes, load test int float. Okay, command loss does not exist. Here exactly the example. So here I've asked to oh, I'm still on that, so I need to go back to the coding. Sorry. Here you see I've got the call to display an int to display a float, two internal functions from Arduino. So I got my first equation, float f1.3 plus 1. I'm going to display the float, all the functionalities I gave you here, the example I gave you. So if I execute that, we see the first one give you 155, as I said, second one 3, the last one, the third one 1, and the first one 4. Okay, so that's how I do the conversion of the types, which is kind of mandatory to be able to deal also with float. Let's go back to the presentation. Don't know what I have left. Okay, so what's inside the control, the compilers? You can do floats, char, ints, uint 32, 16, CRGB, pointers, we'll see that later, variable, global and local variables. Array are always in global variables because I don't do dynamic memory allocation. Sorry for that. Branching, if, then, else, break, continue, while for. Oh yes, break and continue should be in the while for. Functions, import functions from the library. Define preprocessor, write function in assembly directly. Yes, because I've got my assembly directly compiler, I can write function in assembly. For instance, for everybody who knows the ESP32, you know that you get the time by reading a special register by WSL. So let's clear. I'm just gonna set the highlight. Oh, I'm gonna do copy paste. Okay, so now I set the highlight to be SC, so as soon as I'm inside of here, I will be able to write directly with the color. So external, I'm gonna write display int h, I don't care, int main, and I'm creating a function that I will call melee. Okay. Oh, yeah. Okay, but by reading these functions, I need to get into assembly language. Actually, I could create a call to the milliseconds, which is in Arduino, but yes, why do that when we can do something else? Oh god, I erased the controller. Yeah. uint 32 t really. So how do you write a function in assembly? You just write assembly language directly. But because I don't remember the name of the VS Code. I don't remember the name of the register to read. I'm just gonna do that. 2 minutes. Window. Time. Yes, 32. Okay. Here it is. What am I displaying, by the way? Yeah, it's still coding. Let me see OBS, because sometimes, okay. I'm here. I'm just copy that. Okay. So that's reading the special registry 234, which is give you the count of cycles. But I need to divide to get milliseconds by 234, by 240 and 240,000. So move A13 240. QE A14, A14, A13. If you don't follow, that's not really important. And I'm going to copy that line, Control B, Control C. And then I'm going to put that back into the result. The way it's built, the way I built, the way I built the exchange in between functions is a bit special, but we are not here to learn about it, just to 14, 4, 0. Okay. Test milli, C, compile. What have I done? Oh yes, it's not the right function. It's not move, it's movie. Yes. Oh. What did I do? That's why you write, what's what happened when you write assembly. Yes, I forgot to return. Yes, I can rerun it again. And you see it's including. Okay. So you can write function in assembly, and what I've done is actually I've created a certain number of function that I wrote directly in assembly that you can call by doing an import. And for instance, if you look at the ball code, at the top you've got import function, and import trends actually is gonna import the functions directly in assembly, which gives you a random number, and it takes as a parameter an integer between 0 and 1 and whatever, and will send you back a value in between these two. And you can create also, I'm rebuilding all the if you look at all the animation, because I need the time function and the milliseconds, but the delta in milliseconds, I've built here in assembly some functions, which is actually faster than calling a function which actually is stored within the stack. Okay. See people here. If anybody's got questions, just let me know. Let's go back to the presentation for a couple of last slides. Oh yes, the define function. Yes, let me just go back to that. If Control E. So here the define. So either you can create a variable, or either you can create a define, but the define is better if it's actually global variables that you want to put everywhere in your code. And of course, you can do this. That will work also. Let's go back running the balls function. Up, yeah, you see, changing, not really too much of an issue. Oh, why did I stop the program? Maybe it's too load square. Okay. Oh, I didn't save the. I let that commented because I want to come back to play with the variable control. Okay. Why do I always stop the program? Keynote. Okay. Excellent. What about performances? That was a good point. Is it really performant? Do I lose a lot of time? So between Pixel Blaze and RTFX, I don't know. If some people who chat come back, please do not try to come back to me with some performance number. What I could actually measure is actually that the performance between the script here and what you could get by directly coding within Arduino IDE. So between the better version of the assembly language is between 20 to 20% slower than the optimized code produced by Xtensa JCC. Okay? But it's actually way lighter. I know I've already identified way of improving the generative assembly. I just need to work on that, and also the stack management in the function return that could be also improved, so you could gain also in speed. Okay, but that's another story. Okay, just a minute. Sorry for that. I was using my iPhone as a camera for the panel, and it didn't have any more memory, any more battery. What is missing still? The comparison functions between float and integer, because in Xtensa, in assembly Xtensa, it's totally different between integer and and float. It's actually not even that's not the same functions, but the way you do it is totally different. So I just need to get into that to implement comparison between floats and integer. Boolean functions, you see that I had to write to define h equals something, and I couldn't write while true. I need to do that also to define the Boolean expression. I'm not still able to write a combination of tests. I did not create that. All the function minimum, maximum, ceil, floor, etc. Absolute, but I've made absolute value inside the code. Actually, you've got actually language machine function, machine language function existing. So I need to implement them. That's just the time to do so. And also I want to be able to create objects, not class, but more structure at least, to be able to ease the parameter or more complicated animation. Also, the next step is actually that now I've done the proof of concept that you can have the editor within the console running on the SP32, but you're not going to plug on to your SP32, but you could actually create the code on the web editor, send it to the SP32, the SP32 will compile it and do that. The next step after that would be actually to do the compilation in the web. As I've got everything in C++, I know that you have a way to move C++ to WebAssembly, and I will try to move all my code so it runs everything on the web. And I only send the binary to the SP32. Yes, I think we'll see functionalities, as I said earlier, improve the language performance. Okay. Side effects. Oh yes, side effect. First one, that's a good one actually, because extensor is actually common for S2 and S3, even if the processors are not exactly the same. It works without any changes on an S2 on an S3. So you can take I diffuse it. I tried it on an S3. Actually, I don't have any S2 around, but I've tried it on an S3 and it works fine. So if you have an SP32 S3, no problem. And it's a general scripting language with pointers. So I'm gonna go back to coding and change something here. I'm gonna move that down. Just so you can see, you don't need to see. Okay. Here I'm on my second SP32. It's not exactly, it's not plugged to anything really, but it's actually plugged to no, it's not what I want to do. That here I am back. It's plugged to logic analyzer. Okay. So I'm gonna load blinking. Okay. Yeah, set time also. I don't care about that for now. For those who know a little bit of ESP32, outputting data on pins actually read and write on certain registers. And because I can manage pointers, I can do this here. I'm gonna look to the pin 22, so I'm gonna wait for it. And I'm gonna run the program. I'm gonna go Control RX here and up. You see that, yes, it's normal because it's too much in loop. That's normal. So you can see I was able to output data on a pin. Here it's 10 megahertz because it's really slow assembly language for now. But I'm gonna improve that, so you can do pin in, pin out, and reproduce. I could actually reproduce every functionalities of the SP32 that you find into Arduino using assembly language. But here it was not even using assembly language, it was only using pointers. Like you will write exactly the same code on C. So if you take that code and you write it in C, it will do exactly the same effect on your SP32. That's what actually is nice. That's why I can transpose almost everything that I want inside C, because it's more general purpose programming language that's more focused to Let's by itself. Just a minute. So yes, you can also you could actually interact with I2C components directly from the code here, etc., and everything. But even if I think that if you should get that, use external function, lib them by the add external functions functionality of the parser, and use them like this. But it was nice to show that you could actually do that. Let's bring back this. And me also. No, something has changed. Anyway, oh, something went wrong. It's not working anymore. Okay, anyway, that's not the issue. Okay, no problem. So we're back on the side of the panel. So here, if you have any idea of any script that you would like to see running, just tell me. But yes, I guess. Oh, I could also do that actually. I could say that I want it to run only on 64 by 64. And everything could be defined at will, depending either directly calling a variable directly from your code, or simply creating a parameter that will evolve around time. And let's put 100 balls. That's a lot of balls for such a small space. So let's keep it back. 100 by 96. Yes. So I let you with that. Let me know in the comment what you think about the scripting language, its speed, its capabilities. If you would like to have access to the source code, please let me know. If you want to have a part 3 with the evolution of it, let me know also. Okay. Thank you a lot. See you next time. Bye bye.